Here's a quick video on similar triangles. So similar triangles are, of course, two triangles that are the same size and shape, but just like triangle congruency, there's some different ways to show and demonstrate, or prove, if you will, that two triangles are in fact similar. And one of those ways is to use what is known as SSS, similarity. So SSS similarity says that if the ratios of all three pairs of sides between two triangles are equal, then the triangles are similar. And so what does that mean? Well, what that means is that if you have two triangles and you know their side lengths, like we have one triangle here that has 16 inches, 12 inches, and 20 inches for its sides, and another one has 12, 9, and 15 for its sides, then we can determine whether or not these two triangles are similar. So here's how you would do this. Okay, first of all, you want to set a ratio up for each side, and so we know that 16 here goes with 12, so I'm going to make a ratio so that it's 16 over 12. And then we also know that 20 is going to go with 15. Okay, so I'm going to make a second one of 20 over 15. And then thirdly, we know that 12 goes with 9. And the reason we know that is just because of the shape of the triangle, right? So this side is the same piece as this one, and this side is the same piece as this one in this triangle, and this side is the same as this one in this triangle, and so on. Okay, so let me do that last ratio of, let's see, what did I do? Oh yeah, okay, so 12 over 9. Okay, so what we want to do then is we want to go ahead and reduce each one of these ratios. I'm going to pick a different color here. There we go. Okay, so how are we going to reduce these ratios? Well, all you do is you just reduce them like a normal fraction. So I know that 4 goes into both 12 and 16, so that's going to give me 4 over 3. I know that 5 goes into both of these, so that's going to give me, again, 4 over 3. And then I'm going to divide this by 3, and that's going to give me, again, 4 over 3. So you'll see that all three of these ratios are equal. All three of these ratios are equal. They all equal 4/3. So that means that these triangles are similar. So we can say that the triangles are, triangles are similar, and the symbol for similar is a little sideways S. Similar by SSS. Okay. So this is different from the SSS from congruence in that we're looking for equal ratios between the two rather than the sides are the same length. Okay, so that's side, side, side. Let's take a look at the next one, and there are 3 of these. So let's take a look at number 2. This is SAS similarity, SAS. So very similar to the one of that we're using in triangle congruence. If a pair of sides of two triangles have the same ratio and the included angles are congruent, then the triangles are similar. So let's take a look at two triangles. Okay, so here we have two triangles, and we have a pair of sides. We've got 5 for this side and 3. We could maybe make those inches. Do that real quick. And we can do inches here, inches there, and inches there. And so that's what that's saying is that these two triangles then have that and this. So what we need to do is we need to look and see if these ratios equal this ratio, and then we know that the angle in between is both 93 degrees. So let's take a look. Alright, so we're going to look at 5 over 3. And we're going to see, does that equal 10 over 6? Well, I know that I can divide 10 over 6. I can reduce this ratio and divide it by 2. And when I do that, that gives me 5 over 3. And this other ratio here is already reduced. We know that 5 over 3 is equal to 5 over 3. So yeah, those are equal. So the next thing we need to look at is this included angle. So you see here that we have this angle is in between these two. So just like with congruency, remember that it has to make an angle sandwich. So an angle sandwich would be like this, right? So we have there, and then the angle's in the middle. So if this angle was over here, then we wouldn't have an angle sandwich, right? Because we need a side, then an angle, then a side, just like that. Side and an angle and a side. Just like this says, it's like a little sandwich, right, with the angle in between. So if the angle's like over here, it's not really in between, because then we have that side, the angle, and then some side that we're not talking about. So because of this, these are similar by SAS. So we can say the triangles are, oopsie, I went off the page there. Do it right here. Triangles are similar by SAS. Okay, and once again, the little symbol for similarity is this little sideways deal here. This means similar. Keep going off the darn page. This means similar. Okay. And so the triangles are similar by SAS. Alrighty. The next thing we need to look at is angle, angle, also sometimes called angle, angle, angle similarity. Now this does not work for congruence whatsoever. There's no congruent equivalent for angle, angle, angle. But let me show you this for similarity. So for similarity, if two pairs of angles in two triangles are congruent, then the triangles are similar. So here's a pair here. So you see that we have two triangles, and this angle is congruent to that one. This angle is congruent to that one, so we know that these triangles are similar. Okay, so because this one is congruent to that one, and that one's congruent to that one, let me use a different color for those two. Right, these two are the same. Then we know that these two triangles are similar. Okay, so these triangles are similar by angle, angle. Now, why is there a version of this where it says angle, angle, angle? Well, here's why. If you have two angles of a triangle, you can find this third angle in both triangles. And if you were to do that, you would do 34 degrees plus 48 degrees plus the unknown angle equals 180 degrees, the triangle sum theorem. So you can find it in both triangles. And if you solve this for both triangles, you're going to get the same answer. So these angles are also going to be congruent. Even though we don't know what they are, we know they're going to be congruent because we're going to use the same formula to solve them both. So that being said, we can also use angle, angle, angle. It's not necessary to have all three angles, but you can. Okay. Alrighty, let me show you another one. It looks like this. Okay, so on this one here, you see that we have an angle here, and that's congruent to this one. But we also have a second pair of angles, remembering back to when we learned about vertical angles. These two angles here are vertical. So these triangles are also similar by angle, angle. And then let me show you one more example, and that'll finish up the video. The last example would be like this. Now, this one here is a very common one for similar triangles. You'll see that we have a triangle, a large one, and then within that is a small one. But we also have the small triangle and the large triangle have these parallel lines here. So what that means is we actually have parallel lines cut by a transversal. And therefore this angle and that angle, these angles are corresponding. These are corresponding. And I'll show you that here with this highlighter. You can see that you have that, and then you have the two parallel lines. Okay, so you can see your parallel lines cut by a transversal. We have our corresponding angles, so those angles are equal. Now if we have it there, we also have it over here. Here's the transversal, the two parallel lines again. So then we also know that these two angles are also congruent and corresponding. I'm going to get rid of the highlighting real quick. Okay, so those are also corresponding as well. These two are corresponding to each other. So we know that these two triangles, the small one inside and the big one, are also similar by angle. Okay, that's it.